Mid-segments of triangles. So chapter 5 is a lot of triangle stuff again. You do need to make sure that you have tools with you on Thursday. You will either need a compass and a straight edge or a protractor and a ruler. And because you don't know yet which method you would like, I would suggest you bring all of that. So if you bring a ruler, make sure it's a centimeter ruler. It just makes your life much easier. But there's one method that for sure is easiest if you have a ruler. So I would for sure bring a centimeter ruler and then a compass and a protractor, and you should be good. Okay, so if you bring those three things. So yeah, we'll be doing constructions with triangles. We'll be finding all different lines within triangles, which I will explain to you more as we go. Today we are doing a line in a triangle. That was much better. The one we're going to talk about today is called the midsegment. So we're going to define it, and then I will draw it, and we'll call it good after a few examples. A midsegment is a segment connecting the midpoints of two sides of a triangle. Okay, so let's say you have a triangle. Oh. I didn't move my ruler for the last one, and apparently it got a little confused that the ruler was still nearby. That was nice. Thanks for laughing at me, though. That was really nice
We're
of
laughing
you.
with you.
Mm-hmm. Okay, so if I find a midpoint on two sides, so a midpoint right here, right, where those are the same length, and a midpoint over here, where these two are the same length, then your mid-segment is the segment that connects those 2 points. So if I connect those 2 points here, we would call that a mid-segment. Any ideas what might be true about that segment? If you look at that triangle, do you see anything that you think, I wonder if this is true? Indeed. It is parallel. Okay, so that's one thing. Any other thoughts? Yeah, Michael. You guys are good. So two things, okay? And this is called the triangle midsegment theorem. And it says those two things. If you have a midsegment, then these two things. Number one, it will be parallel to the third side. And two, it will be 1/2 the length of the third side. Okay, so that's the triangle midsegment theorem. So what we're going to do is we're just going to take a look at those two ideas with a few different examples. Okay, so first example looks like this. So if you have a midsegment here, and these markings are key, right? If it doesn't tell you that it's a midpoint, then you don't know that you have a midsegment. So make sure that it's marked for you that this is a midpoint, that this is a midpoint, that this is a midpoint, okay? And then if I connect all of those, I should have 3 mid-segments, right? So we would have this one, this one, and this one. All right, so let's label some of our points here. Oh, it's really confused by my ruler, I think. This is A, this is B, C, and then D, E, and F. You know what, I never did mark that up here. I'm gonna go back up to this picture just so you have it in your notes. We know from this theorem that these lines are parallel, right? That's the parallel lines we put there. You also know that if this is X, this one is 1/2 X, if it would write for me. Okay, so the one is half as much as the other. All right, so moving on to this one. We have this picture where we have 3 mid-segments. I want to know which segments are parallel right now. So what is DE parallel to? DE would be parallel to CB. Okay, what other segments are parallel? DF is parallel to AB. And what's the last one? EF to AC. Yes, sorry, I thought you said BF. So AC would be parallel to EF. Okay, so it's always the one, I mean, you can tell when they're parallel because they're not intersecting, right? So it's just the two that are a mid-segment and the side that it's not in contact with. Okay, so that's pretty simple. Hopefully you can find your parallels with that. What if we're going to take that same picture and I'm going to tell you some lengths on it. Okay, so we're going to take AC right here and we're going to say AC has a length of 60 and we're going to say DF has a length of 40. Okay, so that's this length. And we're going to say that CB has a length of 100. All right, so if I know that the lines are parallel, and I know that one is half the length of the other, can you tell me what, let's go with EF. What would the length of EF be? Yeah, it's right here. It'd be 30, right? If this is the one that it's parallel to, that has a length of 60. So you take that 60 and you cut it in half. So we would say EF is half of 60 or 30. Okay. Can you tell me the length of AB?
Yes.
What is it?
80.
It would be 80 because parallel to that is this 40, right? This one's 40. So if DF is 40, now here's where I will tell you right now, I believe that every one of you in this room can tell me that if that is 40, then this one should be 80. Yeah, I know, we're good. I'm gonna write out the equation in just a sec, but my issue is a lot of people will see the 40 and you're so used to cutting things in half that you'll tell me the other one is 20. I know you don't believe that this line is shorter than this one, right? If you stop and think reasonably about it, that doesn't make sense. And I know you know that, but people are gonna rush and people are gonna do it. So Don't be the one that does it, is my request, okay? Because if all of you don't, then it doesn't happen anymore. So just pay attention to what makes sense. If that segment is 40, then the segment across from it, AB, would have to be double that, right? So we would say AB is double 40, so AB is 80. Okay, so what does that mean for, where are we at? DE. What's the length of DE? DE would be 50, right? Because this side here is 100, and if that's 100, then the segment across from it has to be half as much. So we're going to say, DE is going to be half of 100, or 50. Okay? Thank you, Ryan. Any questions on that? So I feel like if it's just a number like that, it's either you cut it in half or you double it. It's pretty straightforward. Where I think people start to get a little more confused is when they throw an expression in instead. So let's take a look at an expression here. So this is example 2. Oh, there goes that ruler again. This is a fun little adventure with the ruler out. Let's say you have a triangle with a midpoint here and a midpoint here. So this is your midsegment. And I tell you that this is x minus 1 and this is 52. What's the relationship between these two? How do they relate to each other? One is half, and they're parallel, okay? What do you do to solve for x then? You can what? Double what? Okay, so there's 2 ways you can set this up, and I don't care which way you use. I feel like sometimes people forget to use the distributive property, so maybe it's better to use the other, but that's up to you. You could double this, right? So if I take 2 times x minus 1, make sure you put parentheses around it and set that equal to 52. What's the other way you could do it? Instead of doubling x minus 1, you could do what? Yeah.
Divide 52 by 2.
Right. Yes, so you could cut the 52 in half. So you could say x minus 1 equals half of 52. Okay? You're going to get the same answer regardless. So you pick which one of those makes more sense to you, and you do it that way. Okay? I will work out both for you just so you can see it. But if we distribute this, you get 2x minus 2 equals 52. So add 2 to that, and you get 2x equals 54. And then divide by 2, so x is what? 27. Okay? If you do the other route, then you get x minus 1 equals half of 52 is 26, and then you add 1, and you get x equals 27. Okay? So I don't care which one you use. What I do care is that you don't try to use both. I've had it before where people double this one and cut this one in half, and then they set them equal, and that won't work. So make sure you either double the one or cut the other one in half. Okay? Questions on that? Okay. Last question. Do I need to slow down? We're okay? So third example, are any of you swimmers? My last class didn't have any swimmers in it.
I have a pool. I can swim.
You know how to swim. Does anyone swim competitively?
No.
Did you ever swim competitively?
I just
in the backyard.
Couple? You did?
They call me Michael Phelps.
Uh-huh.
Yeah, you're more like Ryan.
I feel like when I was a kid, that's like what we did. We swam. Okay. Well, anyway, this example is made up for a competitive swimmer. I guess we could do something else. Do any of you do row? Anyone crew? Rowing? Crew?
No.
No?
That's not common.
You guys all live by water.
We don't live in a country club.
You don't have to live in a country club to row.
Yes, you do.
No, you don't.
You have to go like Christopher Yale to row.
Oh, to row?
Yeah. You know Yale has a football team and they're actually pretty nice.
Really?
I'm not even joking.
Okay, here's the deal. We're going to pretend that, no, it's a lake.
Yeah.
We're going to pretend that you swim, because I swim and I like it. Well, I used to anyway. It's been a long time. Here's the deal, okay? There is this kid who is on a swim team and has to practice daily, but he's going away on vacation with his family. So he leaves to a lake, but his coach says you have to swim X number of miles every day, okay? And there's a lake there. So he's going to swim across the lake, but he doesn't know how far it is across the lake, and he's a rule follower. So he wants to make sure he swims as much as his coach says, okay? He's a me. Don't you bag on those. I am a rule follower. Rules are for sure not a problem. No. I disagree. Okay, so here's the deal. We don't know how far it is across the lake, right? We don't know this distance, but we can figure it out by taking a little trek by foot on land, not the water. So here's what we're going to do, okay? This kid is going to walk this way until he gets to a point where he could walk straight across. He's going to put a little stake in the ground, okay? And we're going to say a typical stride is like 3 feet. So he walks 35 strides. Okay? Then walks 35 more. That's why I'm going to show you, so you can someday just impress people. So he walks 35 more, which means, put a stake in the ground. What is this? The X? It's a midpoint, okay? We're working on a mid-segment here. Do you see it? What do we have to do next to get a mid-segment? We got to come the other way. Now here's the thing. We want a midpoint. How can I make sure I have a midpoint?
Yeah, we don't know.
Measure it. You measure it.
Measure it how? Okay, but we're walking it off, right? It's paces. How can I get a midpoint?
Go halfway between.
How do you know what halfway is?
You add up how many steps you've already done, and then cut it in half.
But this side's not the same length as the other side.
You do it on the other side.
All the way.
Same thing.
You walk all the way, right? So we're going to walk all the way across this way. We cut through the lake a little bit. Right? This is talent. So he walks 236 paces here and wants to get a midpoint. Oh, no, he's got to do his swimming. So once he gets here, he's going to walk back how far? Halfway. Cut that 236 in half. So he's going to walk back 118 paces to this point here.
I love this kid to be my friend.
I know, he's so cool, right? Okay, so once he gets here, how can he figure out the distance across the lake? The mid-segment, right? If he walks the mid-segment, I kind of missed, sorry. So he walks that off, and it's 128 paces. How far is it across the lake? Multiply that by 2. So 128 times 2 would be 200. Oh, there's that ruler. It's my ruler, I promise. You can't see my ruler. So he walks across. I just lost my lake. So it's 256 paces. And we said a pace is about 3 feet. What do you have to do with that number then? Multiply by 3. So 256 times 3 comes out to 768 feet across the lake. So depending on what his coach told him he had to swim, he knows it's 768 feet across the lake. If he had to do miles, he's got to do a few laps. Questions on that? So if you ever need to measure something that you can't measure walking across it, you can measure walking around it, right?